Hi everyone, hope everybody is good. So today I'm going to explain about closure properties of context-free languages. So let us consider we have a context-free language. By using closure properties, we can prove its related languages are also context-free languages. So let us consider the first property that CFLs are closed under union operation. So let us consider a context-free language L1 generated by the grammar G1 equals to, we know the definition of the grammar that is given by V, comma, T, comma, P, comma, S. So we're taking L1 generated by the grammar G1, variable V1, T1, P1, S1. Now let us take one more context-free language L2 generated by the grammar G2 equals to variable 2, comma T2, comma P2, comma S2. Let us take a new language that is L equal to L1 union L2. Then G equal to G1 union G2. Now, how do we write this new grammar? G equal to, that is given by V1 union V2. Now, all these variables are nothing but the unions of the language 1 and language 2. Now, T1 union T2. That is the terminals of the unions of both the languages. Now, let us take production as P. Now, this can be written as V and this can be written as T. Now, let us take a new symbol, that is starting symbol, that is S. Now, what is V here? That is V is V1 union V2. Now, let us introduce one more non-terminal S. Now, T is T1 union T2. Now, what is the production P? P is P1 production from the first grammar in this language, union of production from the second grammar from this language, and we are adding one more production, that is S tends to S1 slash represents union operation here, that is S1 S2 union S2. Now hence we can prove that context-free languages are closed under union operation. So now let us discuss similarly about how CFLs are closed under concatenation operation. So if the two languages are concatenated, then the resulting language is always a context-free language. So that is the use of this closed under concatenation property. So similarly, let us try to prove. Let us take L1, which is a context-free language, and G1 is a grammar generated by this context-free language. So given by V1, comma T1, comma P1, comma S1. Now let us consider L2, another context-free language generated by G2, V2, comma T2, comma P2, comma S2. Now how do we perform the concatenation of the two languages? L equal to L1, L2. It means that G equal to G1 concatenation G2. So how do we write this? So the new grammar G equal to V comma T comma P comma S. So what is V here? V equal to V1, that is the variables from the grammar 1, union V2, that is variables from the grammar 2. Now let us use one more new non-terminal S. Now terminals equal to terminals from first grammar union terminals from second grammar. Now production P equal to production from the first grammar, union, production from the second grammar, union, introducing one more production, that is S tends to S1 concatenated S2. So this is how we can prove that two context-free languages are closed under concatenation. Now let us see how it is closed under star closure operation. So let's take L1 is a language generated by the grammar G1, which is defined as V1, T1, P1, S. Now the closure of the language can be written as L closure grammar G equals to V, T, P, S, where V equals to variables, T equal to same the terminals, and P is equal to introducing new production to the existing productions, that is P1 union S tends to S1 S slash epsilon. Now how to prove this? For example, I have S tends to S1 S slash epsilon. Now what is the first thing generated by this epsilon? Now S tends to S1 epsilon. Now what is the resulting thing? That is the S1. If I replace it S again with S1 S, then S1 S. Now if I replace S with epsilon, what does it derive? S1 S1. Now if you replace S with again S1 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 again, so it derives what? Epsilon, like S1 S1 S1. Again here S1 S1 S1. So hence the context-free language is closed under star closure operation. So now let us prove how context-free languages are not closed under intersection operation. So to prove this, let us take a context-free language L1, that is equal to A power n plus 1, B power n plus 1, C power n, such that n is greater than or equal to 0, which is a one context-free language. Now take another context-free language CFL, that is L2 equal to A power n, B power n, C power n plus k, such that n comma k is greater than or equals to 0. So by looking at this, we can say that this is actually a context-free language. Now let us take the intersection between the two languages, L1 intersection L2. Now if we do the intersection between these two grammars, G1 intersection G2, that is generated by this one, this is generated by this one. Now we can prove that these two languages are closed under intersection by the grammar construction, but we are mentioning not closed under intersection. Now let us see why I did this. So if I take intersection of these two languages, that is L1 intersection L2, that is equal to A power n plus 1, B power n plus 1, C power n intersection A power n, B power n, C power n plus k. So this new language is nothing but A power n, B power n, C power n, such that n is greater than or equal to 0. So by looking at this grammar, we can say that it is not context-free language, it is context-sensitive language. So by using the statement, we can say that it is not closed under intersection. So by using grammar construction, we can prove that it is closed under intersection. But by using language construction, we can prove that it is not closed under intersection. So it is based on contradiction that CFLs are not closed under intersection. So now let us prove how context-free languages are not closed under complementation. So before proving that, let us discuss if L is a regular language and its complement is also a regular language. So initially assume that if L1 is a context-free language and its complement is also a context-free language. So if L2 is a context-free language and its complement L2 dash is also a context-free language, let us assume this. Then uh, the union of two languages, union of two CFLs, L1 union L2 is so based on this union of two CFLs is regular. Now the complementation of two languages union is also a context free language. So based on this, let us convert L1 complement union L2 complement is also a regular language, let us assume. Now if we use De Morgan's law, so that is L1 intersection L2. So this is the De Morgan's law. So we just proved that two CFLs are not closed under intersection. So L1 intersection L2 is not a context-free language. So based on this, L1 complementation union L2 complementation is equal to L1 intersection L2, which is not closed or proved by contradiction. So based on this, we can prove that complementation of two regular CFLs is not a closed operation. So complementation of two regular languages is not closed under complementation operation. Thank you.